Algebra 2, Section 1.1. In today's lesson, in Section 1.1, we will be learning about whole numbers, integers, the number lines, and about absolute value. So, anyone knows what a whole number is. A whole number is any number that is greater than 0 or equivalent to 0. A number line can be said to represent these whole numbers or even possibly negative numbers on a number line. And it can be represented on a number line. A number line is shown right here. It is a line that shows any number which can infinitely go on. And this can specifically represent which number is greater. Any number that is on the right is greater than any number on the left. So in this instance, it's 5 is more to the right than 2. So 5 would represent a greater amount of value than 2. And in another occasion is that 8 is obviously in this number line shown to be on the right side of the number line, and 2 is on the left side of the number line, which can be shown that 8 is greater than 2, or 8 is greater than 3, or 8 is greater than 4, due to 8 being on the more of the right side of this number line. And the next step we will be learning is the opposite or additive inverse of a number, which is also known as the negative number. So the additive inverse or the negative number can also be known as an integer. An integer is any number on a number line that is to the left of 0. So a whole number was any number that was to the right of 0, which is known as a positive number. And any number that is to the left of 0 is known as a negative number, or also known as integers. So let's say that A, B, and C represented elements of any set of integers. So an addition is closed as A plus B is an integer, and A plus B equals B plus A. That's obviously common knowledge that if you could add both sides, you could flip them over to equal the same thing. And A plus B in parentheses plus C equals to A plus parentheses B plus C. In overall, it would equal the same thing. And A plus 0 would obviously equal A, and but an integer has an inverse. A plus negative A equals to 0, which is one of the elements of this integer. So let's say if A equals 10, then it would be 10 plus negative 10, which would equal to 0. This could be any sort of number. So it could be even 1,000 plus negative 1,000. It would be equivalent to 0 in the end. So that is what integer and the number line is. So next we'll be learning about subtraction. Many of you may know that subtraction is just any number that is subtracted by another number. But any number, when it's subtracted, it has to equal the opposite of the number. So if we were to say A minus B equals C, then in the end, B plus C would have to equal A. This would be the only way for subtraction, and this would be the main definition of what subtraction is. So let's solve the equation by saying B plus C equals A, and we would be solving for C. So B plus C equals A, and we would have to subtract B on both sides to make the C by itself. So it would be C equals to A plus negative B, which would resemble the same as B plus C equals to A. So therefore, A minus B equals to A plus negative B. So that's what subtraction is represented as. Next, we will learn about absolute value. Absolute value is any number, even if it's a negative, but within the absolute values, it would turn into a positive number. So let's say if A was greater than 0, then absolute value of A would equal A minus 0, which would in the end equal A. And if A was less than 0, then if it was in the absolute, it would equal 0 minus A, which would equal negative A. But if it's in the absolute values, it would turn into a positive. So let's say that, for instance, 5 was greater than 0. Therefore, 5 would equal to 5 minus 0, which in the end results into 5. And let's say if it was negative 5 was less than 0, and it was in the absolute value parentheses, it would be 0 minus negative 5, which would result into 5, because if two negatives are stuck together, then it would result into making it a positive number. We can also say that absolute value of a number equals the absolute value of a negative number, which results into equaling the same thing, or it would equal into the same positive number. And something in an absolute value would never equal to a negative number. So let's try these equations right now. So one of these exercises, it explains that Tina is 3 years old and knows how to count. Explain how you would show that Tina knows that 3 plus 2 equals 5. So in this occasion, we would be using the subtraction method, which we would be solving for A. Solve for A, which would be 2 in this occasion right here. So we would have to subtract 3 from both sides. Subtract 3, which result into 2 equals 5 minus 3, which would resemble 2. So that's how Tina would know. By using the subtraction method, we could know that Tina knows her subtraction, and that in both ways, it would result into equaling 2. 5 minus 3 would equal 2, and 3 plus 2 would equal 5. And let's go to the next few quick. We'll do some practice problems on absolute values now. So the absolute value of 6, like said, it makes it anything a positive number. So it would be 6 minus 0, which would equal to 6. So the absolute value of 6 would be 6. Let's try number 4 now. So the absolute value of negative 12, and what absolute value does is make any negative number into a positive number. So in this occasion, the absolute value of negative 12 would result into equaling 12. And for questions like number 10, where it has negative 8 plus 8, it would result into 0, but 0 can't be a positive or negative number, so the answer would just result into it being 0. And for equations like this, the absolute value of 3 is just positive 3, minus the absolute value of positive 3 would just be 3, which result into 0 as well. So now let's use the subtraction method to define if the subtraction is true or not. So in this occasion, we would have to solve for A, which A would be 5. So we have to subtract 8 on both sides, subtract 8. And it would be negative 5 equals to 3 minus 8, which would result into it being true, which we know that it is really a subtraction, and we just defined it this way.